Hey everybody, Mr. Sharkey here with another exciting chemistry video. Today, we're just going to go through this bond character review to make sure we know how to classify bonds and try to figure out if they are more ionic, covalent, or metallic. So this review PowerPoint does go through a lot of the stuff that Mrs. Cat talked about in her notes video. So if you haven't watched that, I would go back and watch that. Make sure you have all these notes filled out about the different bond characters, and make sure you filled in your bonding triangle and then color coordinated with all the different electronegativities, and then colored in these different regions on your periodic table. So we're kind of going to skip through that, and in the absent student agenda, or if you're just following along at home, you should eventually get to this slide, and this is where I want you all to start. So these 6 compounds, I want you to see if you can draw particle diagrams, come up with chemical names, and then try to predict the primary bond character and provide evidence. In the past, when we've talked about ionic versus covalent, or at the time we used the terms ionic and molecular, we talked about metals and nonmetals. Now we actually have a little bit more information since we've started talking about electronegativity, and we want to try to figure out what's happening in terms of electronegativity. So when we're approaching a question like this, the one thing that you're going to need is actually on the whiteboard behind me, but I'll draw it here on our screen for us. We're going to need our bonding triangle. So this is something that we hope you guys are going to become familiar with. On our x-axis, we have the atom with the higher electronegativity. On the y-axis, we have the atom with the lower electronegativity. And then we had this triangle that we split into 3 different sections. Metallic, everything has a low electronegativity. Covalent, everything has a high electronegativity. And ionic, everything, one thing is high, one thing is low. On an assessment, you guys would be expected to know this triangle and to know where these cutoff points are. So for instance, the cutoff between metallic and the rest is at 2.2. So that means if your more electronegative atom has an electronegativity less than 2.2, you automatically know you have a covalent or a metallic bond. Excuse me. The cutoff between covalent and ionic happens at 1.7. So if my less electronegative atom has an electronegativity higher than 1.7, I'm going to end up in the covalent region. So you guys will need to use this triangle in order to answer these questions correctly. Let's go ahead and look at this first example, NO2 together, and we can chat about it. And then if you need more help, you can check the key and then ask your chemistry teacher if you have specific questions. So if we look at NO2, I'm just going to draw on this slide. The first thing we need to do is draw a particle diagram. Hopefully at this point that seems familiar. NO2, I'm going to start off by drawing my nitrogen. Apologies that my circles aren't perfect. And then there are 2 oxygens, so I'm going to go ahead and draw an oxygen on each side. And boom, I've got my NO2. It should look something like this. If I wanted to come up with a name, I could look back and I could say, okay, nitrogen's a nonmetal, oxygen's a nonmetal. I should use my molecular naming rules. So I can call this nitrogen dioxide. Those are just our molecular naming rules. The prefix di means 2. So since there's 1 nitrogen, we say nitrogen, 2 oxygens, dioxide. The tricky part, the part that I wanted us to focus on in this video, is predicting the primary bond character and making sure we provide evidence. So right now, the thing that we should be used to and should seem familiar is recognizing that we have a nonmetal bonded to a nonmetal. So that is one piece of evidence. But now that we have our bonding triangle, we can come up with some more convincing evidence using electronegativity. So to do that, we need to look up the electronegativity of both nitrogen and oxygen. To do that, you will need your periodic table. We'll be looking at the front side, which is, we've got smaller boxes on this side. And the electronegativity is given in the bottom right corner of each entry. So if I look at nitrogen, nitrogen has an electronegativity of 3.0. Oxygen has an electronegativity of 3.5. If I'm trying to figure out what type of bond exists between this nitrogen and this oxygen, the same type of bond will exist between this nitrogen and this oxygen. So I don't need to do the work twice. I just need to figure out what type of bond I have going on here. So I'm going to come back to my triangle. The more electronegative atom is oxygen at 3.5. So I'm going to come over to 3.5. Remember, my vertical line is at 2.2. So 3.5 would probably be somewhere in here. My less electronegative atom is at 3. So I'd have to hop up way above that cutoff point, and I would end solidly in the covalent category. So if we wanted to add some extra evidence, which we do, we could say that our more electronegative atom is above 2.2. Sorry, I can clean that up a little. It's not my best greater than sign. Hold on. More electronegative atom is greater than 2.2. Our less electronegative atom was also greater than 1.7. So this information all helps us conclude that we have ended up in the covalent category. So we've got two different pieces of evidence now. We've got the non-metal bond and the electronegativity of both. With that in mind, I want you guys to go ahead and pause the video and see if you can work through these other examples. And then you can come back and check the key to make sure you have things correct. And if you do have any specific questions, please reach out and let us know. The one example that students have struggled with in class is this NaOH, because all of a sudden there's 3 atoms. Think about what this OH means, and then focus on the bond between Na and OH. So that's one bond character that you can define. And then think about what's happening between O and H. So that's a second bond character you can define. So you're going to end up defining 2 different bonds here for the NaOH section. You'll have the bond between Na and OH, and then you'll have the bond between O and H. So if you want to split that one into an A and B, to think about both of those bonds separately. Go ahead and try those. Rather than making a full video key, I think I'm just going to make a regular key, and then you guys can come back and check that. But that's my plan for now. So go ahead and try these and check the key when you're done. Thanks.